And Mark, whenever you're ready, you can go ahead. Don't forget to unmute.
Got it. Okay. So I'm Mark Rednauer, and I've been working on the MGIS program here for going on 2 years here pretty soon. Kind of taking one class at a time when I can with work. But for my 596A and as the setup for my 596B, I will be presenting on augmented reality as a geospatial enabler for intelligence, surveillance, and reconnaissance. The outline for what we're going to talk about, we'll start with an introduction of kind of myself and my experience with this subject. We'll provide a little bit of background, which was mostly informed by literature review. We will talk about methodology, goals and objectives, my projected timeline, and finally my anticipated results. Introduction about myself. That's me and my 4-year-old son. I have been in the Air Force for 6 years. I'm commissioned in 2015 through Officer Training School in Alabama after working in marketing for a few years after college. I'm from Ohio, born in Cleveland, and lived in Columbus for a little while after college. But so my marketing degree is there from Mount Vernon Nazarene University, which is a little Christian school not too far from Columbus, Ohio. And I'm an MQ-9 Reaper instructor pilot with over 2,000 hours now and over 500 hours of instruction. That is the, if you're not familiar with that aircraft, it's the remotely piloted aircraft that makes the news every once in a while for a high value target strike. And I have obtained the post-baccalaureate certificate from Penn State during the course of my studies for geospatial intelligence applications. That's kind of my background with intelligence, surveillance, and reconnaissance. So background on the subject, kind of just starting very broadly, information so that I can kind of share the way that my perception of information has been formed through my military experience. It's one of the 7 joint functions of warfare prescribed by the U.S. Joint Chiefs of Staff, who basically are the creators of doctrine for the entire Department of Defense. The definition that has been provided is deliberately integrating with other joint functions to change or maintain perceptions, attitudes, and or elements that drive desired behaviors and to support human and automated decision making. That's a huge definition that is kind of all encompassing and surrounding without even needing to describe the other 6 functions of warfare. You can see how information kind of creeps into everything. And most doctrine that you'll read from the US military and really other militaries as well describes information as a force multiplier. And I hate to use the term, but you talk about synergistic effects. And it's a buzzword, but that is kind of what information does for the military, is just kind of multiplies the effects of everything else. And of course, there's a graphic there with the 2 circles, and you can see data becoming actionable intelligence. That's kind of what the ISR community as a whole does, and not just the MQ-9 platform, but ISR, intelligence, surveillance, and reconnaissance, gathers, aggregates, warehouses, processes, exploits, disseminates data to cause it to become actionable intelligence. And then you can see the balance there to the right. And this is kind of the struggle, is diverting resources to the access of and massing of information versus using resources for useful organization and dissemination of the information, because they're 2 separate and distinct tasks. And it's easy to throw a lot of resources at one and not at the other. And we've seen some of that in my community, especially with access to and massing of information. It's not in this presentation, but as early as 2017, you can start to find a lot of articles from Department of Defense insiders kind of pointing to the fact that the US military has amassed far more data than could ever be processed, exploited, or disseminated by human analysts in the realm of intelligence. And that's the problem I'm approaching here. So intelligence, surveillance, and reconnaissance, we've talked around it. It's an integrated intelligence and operations function that can be defined as a coordinated acquisition, processing, and provision of accurate, relevant, timely information and intelligence to support a commander's decision-making process. One of the really operative pieces of that is to support a commander's decision-making process. So there's lots of information or intelligence that's out there that is just information that won't ever be leveraged, can't be leveraged, is not useful. And that is what we're trying to focus on the information that will support a commander's decision-making process and to weed out what that information is. Excuse me. ISR is inherently geospatial. The study of where my enemy is, where my enemy was, where my enemy is going, where are my friendly units and where are they going, and where will they meet? All these elements of warfare, whether maritime, whether space, whether air, whether land, is inherently geospatial in nature. Warfare is geospatial, and thus so is ISR. And increasingly, because of that, of course, it's dependent upon GIS science, just like anything else that is heavily geospatial. GIS science has provided the ISR community kind of with a means of interpreting and making sense of the mountains of data. And so the more we're able to lean on GIS science to aggregate and to simplify the data we're receiving, we can kind of make it useful to human analysts. A useful case study, and of course you won't be surprised to hear that the MQ-9 Reapers is what I think is a useful case study to kind of examine how we could approach this problem, and eventually why I think augmented reality is a way that we can start to get after some of these problems with data collection and with data interpretation. So the MQ-9 Reaper, my aircraft, talked a little bit about it. It's a staple of the U.S. Air Force ISR inventory since 2007, a very highly sought after aircraft by ground commanders, and for good reason. It's capable of loitering for a long time. You think of a fighter jet or other airplanes in the U.S. Air Force inventory that are very capable platforms for weapons and intelligence, but can't stay on target for more than an hour and a half before needing to refuel or land. And that is a lot of risk that needs to be mitigated by a ground commander. However, the MQ-9 Reaper can stay on station for 15 or more hours, depending on configuration and how far of a transit they have to endure to get there. But what that equals is huge collection potential. The aircrew, myself being a pilot of this aircraft, we fly through full motion video. So I'm sitting in a room in the continental United States right now in Florida, previously at other places in my career, and flying an aircraft on the other side of the world via KU satellite link. So I am flying through full motion video with a up to 1.25 second delay at times, depending on the health of the satellite link. But what that provides us is kind of a distance from the battlefield, which of course is advantageous, as well as robust reach back capability. What I mean by that is the aircrew, when there are issues that need to be addressed, they can simply pick up the phone in their GCS. We would call it the ground control station, the cockpit, we could call it, and call someone for help if there's trouble with the cameras. We can literally call Raytheon, the contracting company making the cameras, and get help. And that's something that you can't really do when you're flying around an F-16. And so that's an advantage. And then the complex link and network architecture. The MQ-9's got secret networks, top secret networks, unclassified networks, other types of networks that are all being piped in, all providing just data, more than the two-person crew of an MQ-9 could possibly use all at one time. And then the other thing to bring up is that it's a classic example of sensory deprivation, which is typical of remotely piloted aircraft. And this is well documented and studied. MQ-9 aircrew, of course, we have no haptic feedback. I'm literally sitting in a Recaro racing seat, no lie, with a joystick and a throttle and other controls that look like I'm controlling an airplane, but I feel nothing. If I flew upside down, I of course feel nothing. And so that can be dangerous in certain envelopes of flight, just because I cannot rely on any senses except vision. And it's important because of that to strengthen what information I can get through that particular sense. The images on this slide are to help you understand kind of what that link infrastructure is like. The MQ-9 is being controlled by people there in the ground, either via radio line of sight, which would be the downlink, uplink, or at further range via Ku-band satellite command link and return link, which is the way that I fly the aircraft from the continental United States. This is a look at the ground control station. This is an unclassified photo with any classified information has been removed. But this is very similar to the computer setup you would see in any ground control station for an MQ-9. So safety information, navigation, tactical weapons information, moving maps, that's all there. And the main control station is the central stacks of computers. So the pilot's on the left, the sensor operators on the right, and starting at the keyboard and moving up, directly up, that's the stack of main controls. Those are the necessary functions to fly this airplane. So keyboard, and then the heads down display, then the heads up display, which is directly in front, and then the moving map at the top. All other monitors are peripheral screens, we would call them, and unnecessary for flight. But they all contain valuable information that's always dynamic and always changing. However, the safest way to fly this airplane and most effective way to fly this airplane is for most of your attention to be devoted to the three screens directly in front of you. And zooming in further, the heads up display. So on the previous screen, this was the middle screen that is most centrally right in front of the operator's field of vision. I'll refer to it as a HUD, but critical safety navigation information. If you'll draw your attention to kind of the either the full color image or the black and white image, you can start to see just how much information is there and just how important it is for operators to be very well trained on exactly where to look for each of those information, especially in critical situations and emergency situations, to know where I can find my engine bay temperature, my true airspeed, the status of my landing gear. And then on, even behind all that, I've got an image of a target that we are currently prosecuting in some way, whether through intelligence or via a strike with a missile. But this kind of helps you to understand just how much information there is just on the central display. Now, on these peripheral monitors from the previous slide, I'll go back to it so we can look at that. There will be messaging platforms. There will be people in other locations tasking the aircrew with things. There will be other maps, that some of them containing secret information about the location of objects, some others containing top secret information. And of course, the two classifications not being able to mix on those various networks, it can cause a lot of friction, a lot of whiplash, really, with needing to constantly be looking around at different locations. So I felt that augmented reality, since we've got so much information, or at least some form of mixed reality, might be a way that we can help get some of that information off of peripheral displays and onto a central display, for the sake of increasing situational awareness for aircrew. Here's the mixed reality spectrum. I found this in a paper, a fairly recent paper, but the image itself is from 1994. Milgram and Kishino put this forth. It's the spectrum of mixed reality, and it's really, they broke down the discipline and a spectrum from reality all the way to virtual reality. So reality, wholly physical environment, just the way it is now. Augmented reality, physical environment with some virtual interaction. Think like Pokemon Go. Augmented virtual reality is a virtual environment with some physical interaction. And then of course, virtual reality, wholly virtual environment, typically what we imagine when we think of like a Oculus Rift headset, and so forth. So I felt that based on really the descriptions and papers I read of the different types, the different pieces of the spectrum, and the resources that I felt would be easily available and realistic, that augmented reality would be a great way that we could start to kind of solve some of these situational awareness issues that are present in the MQ9 and ISR community in general. So my purpose then is to utilize mixed reality to increase ISR aircrew situational awareness, to decrease ISR aircrew peripheral distractions, and to improve ISR aircrew and reaction time. So my methodology. It's going to be a human-centered design study. I think all of us that are this far into this program are familiar with that, but human-centered design, so really seeking to understand and empathize with the user or stakeholder throughout all stages of the design process. Dahlberg Design is a company that designs human-centered products, and I found this great graphic from them that just kind of describes the process from planning, and then it does a good job of showing the multiple rounds of iteration, which is stressed in most of the literature, as you work through learning, co-creating, testing, measuring over and over again, and then scaling as necessary. And this is all centered around, the human subjects and the intended end users, really. So I've broken into phases. And phase one is going to be an institutional review board. I'm going to get this IRB sanctioned. It'll be a baseline survey, and I'll be distributing it. I've got a method, I've got a means by which I can tap into a large piece of the operators in my community, pilots and sensor operators, which are the two crew positions. There are approximately 800 that I can reach. And I will be distributing this survey designed to identify and quantify situational awareness and reaction time issues with MQ9 HUD presentation. And then I'll be developing it to gather preferences on augmented reality presentation for various specific geospatial data types. So the questions on the survey will get into, exactly this particular type of data, be it a runway or an airfield environment or a building of interest. How would you most easily perceive, what type of presentation would you most easily perceive for that particular data type? Phase two will then consist of myself poring over that data and designing wireframe mock-ups to basically come up with examples of utilizing their feedback to determine what I feel they're saying is the best way and most effective way to illustrate this type of data through augmented reality in an MQ9 environment. And then finally, phase three, a follow-up IRB sanctioned survey seeking the same aircrew preferences for various data presentations, and then quantifying those answers as well as their reaction time, having been presented with the wireframe mockups. And I alluded to the data types Some of them are static and some are dynamic in terms of what I feel would be useful to represent through augmented reality. Just about everything can be geospatially categorized. And here we can see I've broken it down by static and dynamic, as well as by air-based and land-based. So everything from airspace corridors, which are essentially, highways in the sky, restricted operating zones, which would be areas in which engagement with weapons could occur, all the way to lightning data or weather, any kind of weather data, which is dynamic in nature, because that's also important to aviators, as well as lots of land-based objects. And all the static ones, generally, we always know their location. So that's probably fairly easy to get. The dynamic stuff is going to be a little bit harder, especially vehicles upon being identified, to maintain tracking of those objects through augmented reality. I imagine that would likely incur it's going to require some kind of artificial intelligence technology, and I will likely consider that to be outside the scope of this paper, exactly how artificial intelligence would be employed, but I recognize that's the case. My goals and objectives show that augmented reality can and should be used to increase aircrew situational awareness, decrease aircrew distraction, improve aircrew reaction time, and to implement augmented reality in the MQ-9 airframe, and eventually all U.S. Air Force ISR platforms. My timeline, this is just my phase slide again, really, with timelines laid out. So beginning in late March 2022, tentatively, phase 1 is going to take me 8 weeks to get through developing that survey, get it approved, which the approval process takes about 3 weeks at least, and getting through that first phase. The second phase, I expect, will take me 6 weeks to produce wireframe mockups of sufficient quality. And then finally 4 weeks for my phase 3, which is the follow-up survey and the final analysis of them. My anticipated results. I expect that aircrew of both crew positions do feel distracted by the current attention flow that's required in the GCS or the cockpit. I expect that aircrew of both crew positions do perceive inefficiencies in the current GCS's situational awareness tools. I expect that aircrew of both crew positions desire process improvement for representation of spatial data, and the data representation preferences, I don't know. I will be surprised at probably whatever the results are, but I'm really interested to find out exactly what pilots and what sensor operators think about how data should best be augmented onto our screen. And I'll check out the chat now to see if any questions have been posted, and I'll take a question. Let's see if there's anything to address here. Are we going to differentiate in any way among the 800? Yes. The ways that I'll differentiate, definitely by crew position. So pilot and sensor operator is going to be by far I think the most useful delineator. But I will do age as well, because I'm interested to see if that will play into the kinds of technology that people were raised with and such and familiar with. I don't know that I'll get much further than that. I didn't intend, I don't think, to ask about gender or any other common survey delineators, but I would be open to any other types of delineators that someone feels might be important. Oh yeah, and flight hours as well. Yeah, the second part of your question. Yeah, flight hours will be another part of it, and for us, that is really how we measure experience. So in other career fields, I think rank is more operative, or time in service. But for us, like flight hours is absolutely kind of the primary experience delineator. So that'll be crucial to include. Do I envision design challenges surrounding perceived objects versus real ones? Yes. here's a great example of that. A restricted operating zone, which we would call a ROS, is, I mentioned it in the presentation, it's a circular airspace container within which an aircraft has been approved to engage with weapons. So it'll have a center point and a radius. And at the end of that radius, it's just the end of a circle. So if you can envision an aircraft flying inside of a large cylinder, essentially. And I do think there might be some challenges that could possibly be addressed with the translucency of the object, regarding like what it looks like when an object that you're inside of ends, and how you could accurately perceive that from a full motion video. So yes, there are going to be some design challenges with objects like that, and that'll apply as well with real objects on the ground, especially when an overlay, when we have an overlay of an object on top of the real object. And for that reason, any of these technologies that are developed will need to be able to be toggled off, especially because there are different phases of flight that require different amounts of attention. And one example of that would be a weapons engagement. In a weapons engagement, the aircrew suddenly cease to care about just about everything other than safety. And so anything about like cloud layers, anything about non-critical objects, I would like to be able to toggle off in those types of scenarios. How representative are these 800 crews of the population of such crews overall? I thought about this. There's an email distro and there's a Facebook group, and that's what I'll be leveraging. It's a private Facebook group, and I trust the people who are in it. But you have automatically kind of limited this down to people who have Facebook, which itself probably implies some certain demographic limiting. And I won't, without data in front of me, I won't try to guess at what those limitations are, but that is a challenge. And I'm going to be using an email distro to try to mitigate that and get around kind of the Facebook bubble. Have I consulted with human factors at Right Pat? Yes, I have, in person. I was out there in October and brought this up to them. They are doing stuff that I thought was close to this with their precision-based airman optimization program that turns out to not be really relatable enough at this time to apply. And I thought about trying to utilize them for eye tracking and other types of stuff that would really help me quantify results on the mock-ups. And they're not in a position right now, at least the elements within the human factors engineering division that I talk to are not in a position right now to really involve themselves in this project. But perhaps after, a solid proposal like this, that I could generate some interest there. And then I probably need to, I'll take this last question from Beth. I'm curious about how many responses you expect to get. Are there other surveys sent out to this group? Occasionally there are surveys sent out to this group. They are generally academic in nature, from, someone who's going to a major or a lieutenant colonel who's going to school and needs a sample group. And that's kind of what I'm doing as well. Yeah, it's been done before. I haven't seen anything close to this kind of subject matter. It's usually, quality of life stuff or morale stuff. So I expect that this will generate some interest because it's unique. And that's all the questions I have in the chat. If anybody wants to throw something verbal at me, I'm ready for that. Otherwise, I am complete. I'm finished.
Great job, Mark. Very interesting. Yeah, it does sound like yours will be pretty unique and something that could benefit them. So maybe we'll get a lot more responses than typical other things that go out. Very good. If you want to go ahead and stop sharing, and then John can start sharing.
Mark, this is Steve McKeag. I did want to ask you, Are AR or VR solutions going to be in your survey?
I had sort of decided on augmented reality, and I wasn't going to really even introduce the concept of VR, just because I saw hurdle after hurdle in the introduction of it. But I guess we could maybe even offline, if you want to throw some thoughts at me about if you think that would be like to demonstrate that there's no bias in the survey, including the idea of VR. I think I'd be open to that.
Sure.
John, whenever you're ready, you can get started.
All right. So hi, everyone. I'm John Coles. For my capstone project, I'm building a web application for calculating stormwater runoff from a particular site. The working title is the Virginia Stormwater Runoff Calculator. Let me see if I can get into this. So the goal of my application here, hold on, I'm having a brief technical issue here. Okay. So the goal of my project is to develop a web application which makes it extremely easy for a user to explore current stormwater runoff and pollution generated from an area of interest, and to understand how changing land cover affects these values. I expect the geographic extent to be the state of Virginia, and by extremely easy, I mean that the user should not require any specialized knowledge in land cover types or soil classifications or GIS. So before I get into the details, I'd like to take a moment to discuss stormwater and why it matters. So when it rains and rain falls to the ground, some of the rain seeps into the soil, and this is called infiltration. Infiltration is generally a beneficial thing because it recharges groundwater and gets water to plants, and filters out some of the undesirable stuff. Some of the water returns to the atmosphere via evapotranspiration, or evaporation and transpiration. Transpiration is when water is taken out by plants and then released through their leaves. And then finally, some of the water travels over the surface of the land to streams, rivers, lakes, and ultimately the ocean. And this is called runoff, and runoff can be problematic. What issue here? I apologize. So the issue with stormwater is that as it travels over the surface of the land, it accumulates various pollutants and carries them to surface water. These pollutants can include soil nutrients, typically the macronutrients found in fertilizer, sediment, litter, pet waste, raw sewage, oil, and pesticides. Sorry. The primary cause of stormwater runoff is urbanization. In a natural land cover situation, and so here in Virginia, that would be natural undisturbed forests, there's little to no runoff. Between the natural uncompacted soils and high plant volume, most of the water either infiltrates or returns to the atmosphere via evapotranspiration. However, in suburban and urban areas, there are dramatically more impervious surfaces. These are things like streets, parking lots, and roofs. In addition, and they don't let water go down through them, and so the water has nowhere to go but to run off. Additionally, there's less vegetation to support evapotranspiration, and where there is vegetation such as grass, the soil beneath it tends to be highly compacted from foot traffic and equipment like lawn mowers, and so the water is not able to infiltrate as well. And so this leaves the water really nowhere to go but over the surface. The runoff problem here in Virginia and the entire Chesapeake Bay watershed, the urbanization issue is getting bigger, and so that's leading to more runoff. In the Chesapeake Bay watershed, population is increasing at a rate of approximately 1 million people per decade. However, impervious surfaces are increasing at a faster rate than population. From 1990 to 2000, the population in the area increased by 10%, impervious cover increased by 41%, meaning that even more stormwater volume is becoming stormwater runoff. And to kind of drive that point home, I did a pilot study, which I'll discuss in more detail later, where I calculated the the stormwater runoff from two different sites. One was from a 40-acre site of a big box hardware store here in town. And I calculated that approximately 350,000 gallons of runoff were coming off of that site. A similar area of undisturbed forest, such as in the Shenandoah National Park, which is on the west side of the county, that same area would only generate about 32,000 gallons of runoff, or approximately 1/10 the amount. Shifting gears here a little bit as to what's causing stormwater, I now want to talk about some of the deleterious effects of stormwater, starting with soil nutrients. Like I said, soil nutrients are typically the macronutrients found in fertilizers. Most notable among them are phosphorus and nitrogen. And so it comes as no real surprise that the most common source of these nutrients is the over-application of fertilizer on lawns and turf fields. They're also generated by the breakdown of leaves and other organic matter. And then once they're carried into the waterways by stormwater, I'm sorry, let me get to the right slide. For some reason, my things aren't synced here. And when they're carried to surface waters by stormwater, these nutrients can really support algae growth and lead to major algae blooms. And while this may not seem like a bad thing, too much algae can consume much of the dissolved oxygen in the body of water, depriving all the other aquatic organisms of what they need to survive. Another major issue is sediment. It's another pollutant which is carried to surface waters by runoff. This image here is from the NASA Earth Observatory, and it shows the Susquehanna branch of the Chesapeake Bay following Tropical Storm Lee in 2011. And here the sediment runoff fills the bottom of stream beds where fish spawn and where small organisms that fish and other aquatic life feed on live. And then once the sediment reaches the brackish and salt water, like we see here in this picture, it can bury beneficial organisms like oysters in sediment. In addition, a negative human effect of this is that it can prematurely fill reservoirs and coastal navigation channels, requiring costly dredging. This slide shows an example of a hydrograph showing what would happen in a stream both before and after urbanization or development. And the y-axis over here is stream volume and the x-axis is time. And the first thing to note is that prior to the rain event, the pre-development line is higher, and this is because groundwater maintains the stream level between rain events. But because in a developed area, impervious cover prevents rain from infiltrating, there's less groundwater to keep streams charged, resulting in a lower base flow. When the rain event starts, because of all the impervious surfaces that don't let water through, the water just sheets right off and hits the streams really quickly, resulting in a really high peak of flow. Up here is where flooding might happen. Whereas in the undeveloped land, water infiltrates into the soil, charging groundwater. As the soil gets saturated, maybe a small amount becomes runoff, but we get this much lower, slower curve here. And then after the rain event, everything goes back to the normal base flow of pre-development having a higher base flow and post-development having a lower base flow. All right, so it's not all bad news though. There are stormwater BMPs. Sorry, I'm really having a hard time here with my screen. I should have checked this out better earlier. I apologize. So despite the pretty bad news about stormwater runoff, implementing stormwater best management practices or BMPs, the effect of stormwater can be reduced or even negated. There are numerous types of best management practices which encompass both practices and physical structures. BMPs either prevent stormwater from becoming runoff, prevent pollutants from entering into the runoff, or capture and treat runoff prior to it entering surface waters. Examples of practices include conservation of natural areas, reduced fertilizer use, and picking up pet waste. Physical structures such as biofilters like the ones here capture stormwater, filter it through a biomedia, support infiltration and transpiration through the presence of vegetation and slowly release the remaining stormwater to streams, mimicking the pre-development hydrograph we saw in the previous slide. Most states now require that property owners treat their stormwater generated on their sites prior to it being released, after engaging in any sort of land disturbing activities such as construction. These state regulations dictate that required runoff volume must be captured for treatment and the amount of nutrients that must be removed. In Virginia, these rules are defined by the Virginia Stormwater Management Program, and calculations are defined by the Virginia Runoff Reduction Method, which will be used in the web application proposed here. Taking a brief look here at existing systems that are out there. There are a couple out there. They're all really good, powerful systems. And what I'm evaluating here is how they compare to the goals in my project, such as ease of use, ability to explore changes in land use, and how that affects runoff, and whether or not they require specialized knowledge to use. These are all really useful, valuable, well-designed systems that are just have different goals in mind. The first one that we'll look at is the Virginia Runoff Reduction Method spreadsheet. This spreadsheet is provided by the Virginia Department of Environmental Quality to aid citizens in calculating treatment volume and nutrient loads for land development plan submission. Some of the benefits of the system are it has the capability to calculate subwatersheds, and the output calculations are based on the units and constants specified by the Virginia Stormwater Management Plan, which a user must submit if they're going to be engaging in land disturbing activity. Major drawbacks are that it's complicated and intimidating to use. The user must supply their own matrix of data and land cover and soil hydrologic groups. And finally, the supporting documentation is highly technical. Essentially, this is a tool for assisting engineers and not lay people. However, in Virginia, anyone engaging in land disturbing activities over 1 acre are required to submit this document. Not everybody or every project can budget for an engineer. I work in environmental compliance, and I see too often that when the rules are complicated, people fail to follow them. Stormwater has significant negative effects on the environment and human life, so non-compliance due to complex regulations is just unacceptable to me. That's why for this project, I chose to take on the burden of complexity so that average people can have good access to information about stormwater. So getting off my soapbox, this is a screenshot of the Virginia runoff reduction method spreadsheet. The only user entry here is these green cells, but really it requires it's pretty complicated because it requires you to know what percentage of each of your site is each one of these kind of two-way categories. You know, how much of your site is both forest, land cover, and A soils, both forest soils, or forest, land cover, and B soils, so on and so forth. And really, you need GIS software to do that, which is kind of why I'm here. The next one that we're going to take a look at is the EPA National Stormwater Calculator. This is a really nice system. It automatically builds that matrix of land cover and soil data, and it's user-friendly. The primary drawbacks are that it's not always intuitive to use, and you can't explore how changing land cover affects runoff volumes. This is over my house, and this is a screenshot of where the user would select their area of interest. The two issues that I see is the first one is that it tries to use a buffer area as the buffer, circular buffer to determine where your area of interest is. And you can see here, it picked up about half of my cul-de-sac, but none of the forest back behind my house. And so it gave me pretty skewed values from what I think they should be. I did find later that there is a way here where this hexagon shape is, you can draw a polygon, but it doesn't really look like a button. And so I found it not very intuitive to use. The final system that we'll look at is the Althea system, hosted by Purdue University. This is another really powerful system. Stormwater runoff calculations are just the tip of the iceberg for the system. The benefits are that it calculates very quickly and that you can explore changes in land use. Drawbacks are that, like the Virginia runoff reduction spreadsheet, you have to supply your own soil data. And land cover, they use qualitative expressions of land covered rather than calculated quantitative expressions. So they might say, your land cover is commercial or low density residential rather than just calculating it. And finally, the system is pretty complex to use. Here's a screenshot of that system as well. You can see that it's a bit clunky and probably designed with a more academic audience in mind. By contrast, the system I'm proposing here will be intuitive to use. It will require no specialized skill in soil science or GIS. And the only user input is going to be the area of interest. I came across this quote during my research and it really resonated with me for what I was trying to accomplish. So you'll probably hear it a couple times during this presentation, but the goal of this design is to assume the burden of complexity so that the user doesn't have to, just to make this information really accessible to the average person. So moving on, we'll get into the methods of how I plan to design this system. A few kind of overview topics to get into. It'll be a web-based system, so it'll be built on web-based languages, HTML, CSS, and JavaScript. Web maps will be constructed using the ArcGIS API for JavaScript. Calculations will be based on the calculations specified in the Virginia runoff reduction method. The design will be broken into bite-sized actions to prevent users from becoming overwhelmed with only one action per page. And I'm putting a lot of thought into the user experience. My data sources will come from the USDA and the Virginia Geographic Information Network. The soil hydrology data will come from the Web Soil Survey, and it's available nationwide and downloaded on a county by county basis. The land cover and parcel data will come from the Virginia Geographic Network, or VGEN, and it's downloaded by region. I'm getting into how I kind of plan to take those three data sources and turn them into, how much stormwater is running off of a site. I have to do a lot of geoprocessing. That's going to be a really major component of my project, and it will involve obtaining the land cover and soil group matrix, like we saw in the Virginia runoff spreadsheet, and it'll reclassify those values to get a runoff coefficient. So first, the land cover feature class and the soil feature class are converted to rasters and then reclassified. This spreadsheet here kind of shows the plan for the reclassification in map algebra. The three land cover groups specified in the Virginia runoff reduction method will be reclassified to sequential numbers 2, 3, and 4. And the 4 hydrologic groups will be classified by orders of magnitude 1, 10, 100, and 1000. Using the map algebra tool, the reclassified land cover values will be multiplied by the reclassified soil values, generating 12 unique values for each land cover soil type combination. And this is really what looks like what we saw in that Virginia runoff reduction method spreadsheet a few slides back. And then once we have these values, they'll be reclassified into these values down here, which are the runoff coefficients. A runoff coefficient is a number that roughly corresponds to the percentage of rainfall that will become runoff. So based on the table here, approximately 2% of the rain falling on a patch of forest with type A soils would become runoff. However, because impervious cover blocks the water from infiltrating, no matter what the underlying soil, approximately 95% of rain falling on an impervious surface will become runoff. So now we're here on this reclassified value where each cell represents approximately the percentage of rainfall, which will become runoff, but we need to get a weighted value for the entire parcel. So using the mean property of the summarize within tool, a weighted runoff coefficient will be calculated for each parcel in the state. Following geoprocessing, fields will be added for treatment volume, nutrient loads, and calculated using the field calculator and equations defined in the Virginia runoff reduction method. The final feature class will be uploaded to ArcGIS online to be incorporated into the web application. I do intend to automate some or all of this workflow using Python or Model Builder to help speed things up because it's a lot of work for the entire state of Virginia. This map is based on pilot study I did as part of my final project in GEOG 863, where I did a lot of the geoprocessing and built a less functional web application for just one county in Virginia. The results of the weighted runoff coefficient can be seen in the map above. The dark pink areas are the dense commercial part of town, where there's significant stormwater runoff because the sites, are big box stores and malls and strip malls and that sort of thing. So there's nothing but roofs and parking lots for the most part. The darker blue areas are when we start to get out of town into, various widespread residential and even some agriculture area. So now shifting gears from geoprocessing into actually developing the web application. The first page of the web application is the landing page, and the idea here is everything points towards get started. The idea is that it would be distraction free with no external links. There will be a brief explanation of how the application is useful and who it would be useful for, and maybe a simple tutorial, but not much else. Any links on this page would open as pop-up windows or something rather than external links that would take somebody away from this page. Here's a wireframe of what the first page might look like. As you can see here, there are 3 different get started buttons here, here, and down here. Everything else is minimal. The navigation and status bar across the top is a user interface feature that we'll discuss a little bit later. The next page of the application is the map page. And here's where users will select their area of interest. It will be built using the MGIS API for JavaScript. And the map view's hit test property will be called to select the parcel at the location of the user's click. And then using session storage, the attributes will be of the selected parcel will be stored in the map browser and passed to the results page. Here's a brief video showing my proof of concept for the hit test. You can see that once I select a parcel, the attribute values are logged to the console down here. And so we'll go ahead and run this. You can see that I clicked on the parcel, and now down here on the very bottom of the screen, the attributes are logged to the console. In reality, these will be passed to the results page to display to the user, but this was just proof of concept. I'm sorry. So this is the map wireframe of the map page. It's a pretty simple thing, again, the whole idea is simplicity. And so it incorporates a few user interface buttons to help the user find where their area of interest is and some instructions, but not much else. The final page of the application is the results page. The results page will serve 3 purposes. First is to display stormwater runoff results for the existing site conditions. The second is to explore the stormwater runoff resulting from alternative site conditions. And then finally to recommend site-specific BMPs. The page will be broken into 3 columns, with the first displaying results for existing conditions. The second column will include form elements for users to enter alternative land cover percentages along with the results based upon their entry. And then the last column will recommend the site-specific BMPs to help manage stormwater runoff on that particular area of interest that the user selected. So when the user adjusts their land cover to see how that affects their runoff, the original results are passed from the attributes of the area of interest they selected, but these results will have to be calculated in real time as the user explores alternative land cover values. These calculations will be computed via JavaScript and will include a new weighted runoff coefficient, runoff volume, and nutrient loads. Again, the equations will be derived from the Virginia runoff method. For the site-specific recommended BMPs, a decision matrix has been generated based on site area and land cover types, and it is included in full in the narrative proposal. A few of the decision conditions are described here. For example, a constructed wetland is a physically large BMP requiring 1 to 3 acres of a site, so it would only be recommended if the entire site was larger than 300 acres. And since there's no requirement to treat runoff volume from a 100% forested site, at least a portion of the site would need to be impervious or managed turf cover. Porous pavement, which is another BMP, which allows stormwater to pass through its surface and infiltrate, would only be recommended if the site had some impervious surfaces. And then a final one, which is conservation of natural areas, will always be recommended under all conditions, because even if a site is almost entirely impervious cover, at least a parking lot island could be conserved. Here's a wireframe of the results page with the information broken into 3 columns. The first column shows the current conditions results. The second column contains the form elements for the user input as well as the results. And then the third column includes the site-specific BMP recommendations. This wireframe shows everything that I hope the user takes away from their utilization of this application. I presented it all here pretty tightly for the sake of this presentation. However, to align with the goals of having an aesthetically simple and an aesthetically simple user interface, the page content will be spread out and presented slightly differently in the final product. As I said in the kind of overview of the methods, the user experience is really critical because this can kind of be a complicated and burdensome task, and I don't want people to feel overwhelmed or leave. So I'm taking some tips from the folks at TurboTax who are experts at turning a burdensome task into an approachable one. Some user experience components that they use that I also intend to use are breaking the workflow into small pieces, keeping pages uncluttered, utilizing calm colors to keeping the theme consistent throughout, incorporating a status indicator to clue users in on where they are and what's ahead, and incorporating tooltips throughout the application. Once a functional prototype is constructed, I will begin user testing. This will be an iterative process of obtaining user feedback and making adjustments. Testers will be selected from classmates, coworkers, industry professionals, friends, and families. Recall that one of the goals of this project is that no specialized knowledge is required to use the application, so anyone is able to or is eligible to take it for a test drive. People will be given a task, but not instructions, as that should be intuitive or covered in the tutorial or tooltips. Questions will cover user information, any technical issues encountered, as well as any feedback related to usability. I can go ahead and check off presenting my proposal from my December tasks. Others for December include finalizing my proposal and beginning on my prototype and constructing Python scripts or model builder to handle the geoprocessing. I hope to finalize geoprocessing in January and begin working in earnest on the web application, including finalizing the map page. In February, I plan to finalize the landing page, which includes the development of the tutorial video. March, which I anticipate will be an intensive month, will involve finalizing the results page, checking for issues, and publishing the prototype, and finally creating the user testing questionnaire. In April, I intend to conduct the user testing and make adjustments as indicated by the results of that testing, prepare and deliver my final presentation, and publicly publish the web application. And finally, if all goes well, I really hope to graduate in May. Some areas of future work that beyond the scope of this proposal, which I think would increase the usability of the web application, would be to add mobile device compatibility and the option for the user to define their area of interest by drawing a polygon. Selecting the whole parcel, I think, is a nice way to begin, but a lot of times maybe a user needs to just select part of a parcel or select multiple parcels. In the case, maybe they're creating a new subdivision and they're making it out of several parcels. So I think that would be a really beneficial tool. It is challenging, however, because all the geoprocessing would have to occur in real time after the user selects their area of interest. So I think it would add some processing time to the application and be more intensive, as all of that would have to be done in JavaScript rather than happening ahead of time. So in conclusion, this proposal includes design instructions and processes and considerations for developing the Virginia Stormwater Runoff Calculator. The proposed web application will be easy to use and give the average person access to quality stormwater data and information. I'm passionate about stormwater management because I've seen what can happen if runoff is not managed properly and how beneficial proper management can be. I have seen both in myself and others that complying with laws and regulations often doesn't happen if compliance is unnecessary and complicated. My hope is that this tool will simplify stormwater management compliance so that more people will do the right thing. Thanks for sticking with me through this presentation. For more information, please see my narrative proposal. If you have any questions about this topic after this live recording, I welcome you to contact me at my email address shown on the screen. Thank you so much.
Thanks, John. Really interesting. I'm sure, yeah, there's a question from Fritz already, and then I'll ask mine after you get to his.
Sure, give me a second. I've got to pull Zoom back up.
Might need to stop sharing.
Yeah, thanks. There we go. So Fritz asked, said, good presentation. Have you considered involving any feedback during the early development stage to help direct your UI design? Getting feedback early on may potentially minimize the amount of retooling you may have to do later. Fritz, I hadn't really considered that because I had a pretty clear idea in my mind of what I wanted, but I think that's a really valuable insight, and I could definitely incorporate that into the design. And then Beth said, I might have missed this, but where will this tool be found? I intend to initially publish this just on my Penn State, personal web space. I don't have any immediate plans to have it hosted elsewhere.
And Steve also asked a question above mine.
Oh, can you select more than one parcel at a time? In my current design, no, and that's why I was suggesting that, a further effort would be really beneficial, is to be able to select by drawing a polygon. And I've worked through some really basic prototyping of that, and it really is kind of beyond the scope of getting this application off the ground.
And there's a question from Jonathan. Do you see that one?
Jonathan, with respect to parcel selection, have you considered issues surrounding the modifiable area unit? I have not given any consideration to this, and I'm not entirely sure I understand. I guess I have, and it kind of goes back to what I was saying with that example from the National Stormwater calculator, where they chose to use a circular buffer. And I did give some consideration, and I decided on parcels because I think, and at least in my own experience, and maybe that's pretty limited, I think that I'm most often looking at a parcel, because you're thinking about developing your own land, and not so much what other people are doing. And so I've been mostly considering that. So I think there is some benefit to different areas of kind of coagulating that data for the user to select. But for now, I've chosen parcels because I think that seems like a pretty logical starting place. And then Mark asked, have you checked out the Maryland Bay Restoration Viewer as a possible model for some of your work? And no, I have not. I've looked a lot at I live here in Virginia, and so I've spent a lot of my efforts on the kind of Virginia side because there's so much out there on the Chesapeake Bay, but I will definitely check out this one as well.
Great. Well, that lots of questions for both of you. So that was fantastic. Thank you everybody for joining us. Great job, John and Mark. And like I said, I put that peer review evaluation up there. I will continue to put that, for each of the following days, but, and I will put this recording into the Capstone Project Library as soon as it's done processing. So thanks to everybody for coming tonight, and hopefully we'll see you tomorrow afternoon, or I guess we started, what time do we start? Yeah, we start in the morning, 11 o'clock. But good job all.
Thanks.
Thank you so much.
See ya. Good night.